Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 6A of this CXC CSET June 2013 General Paper 2 Exam Video Solutions. And in this question, we are told that a car is traveling at a speed of 54 kilometers per hour. That's a constant speed of 54 kilometers per hour. And that it takes 20 seconds to travel between two signposts. And the first part wants us to calculate the speed in meters per second. So in other words, we have to convert the 54 kilometers per hour into meters per second. And this can be done by a simple process of looking at the kilometers and also looking at the per hour. And what it is that we have to recognize that 54 kilometers per hour is the same as 54 kilometers divided by 1 hour. That is, a speed of 54 kilometers per hour means that you would cover 54 kilometers in 1 hour. So the aim here is to convert the kilometers to meters and to convert the hour here to seconds. And so what we have is that the 54 kilometers is the same as 54,000 meters. That's it. 54 kilometers is 54,000 meters, and the 1 hour is 60 minutes. So this speed is obtained by traveling 54,000 meters in 60 minutes. And so we can do the calculation, we can divide out the numbers, and therefore that will reduce to 900 meters in 1 minute, because 54,000 divided by 60 is 900. And so this speed is obtained by traveling 900 meters in 1 minute. So 54 kilometers per hour is the same as 900 meters per minute. And now we need to convert this 1 minute to seconds. Now 1 minute is 60 seconds. And so this speed is the same as going 900 meters in 60 seconds. 900 meters divided by 60 seconds now will give us our speed in meters per second. So firstly, we can divide the 900 by 60, and that reduces to 15 meters in 1 second. And so if you go 15 meters in 1 second, you're going at a speed of 15 meters per second. And therefore, the 54 kilometers per hour is the same as 15 meters per second. And that's an easy way to do this conversion. And so that's the answer for that part. 54 kilometers per hour is the same as 15 meters per second. That's the answer for part 1. Let's move down now to part 2. Now what we have so far is that the speed is 15 meters per second. The 54 kilometers per hour is the same as 15 meters per second. And now we are told to calculate the distance in meters between the two signposts. That's what we want. And we know it takes 20 seconds to travel between the two signposts. And so we want to know the distance traveled in 20 seconds when you are going at a speed of 15 meters per second. Alright? So that's what it is. Distance traveled in 20 seconds because it took 20 seconds to travel between the signposts. And so the distance between the signposts is the distance traveled in 20 seconds. And if you travel 15 meters in 1 second, it therefore means that we have to multiply by 20 to find the distance traveled in 20 seconds. And this is it. The distance traveled in 20 seconds, traveling at 15 meters per second, will be equal to 15 meters per second multiplied by 20. 15 meters in 1 second, therefore 15 multiplied by 20 is the distance traveled in 20 seconds. And that reduces to 300 meters. And so the distance traveled in 20 seconds is 300 meters. And therefore the distance between the two signposts is 300 meters. And that's the answer for part 2. Let's move down now to question 6b. In question 6b, we're given a graph with these two triangles, and we are told that triangle L prime, M prime, N prime is the image of a transformation, a single transformation of triangle LMN. So this triangle is mapped onto this triangle by a single transformation. And firstly, we are told to describe that transformation fully. We are supposed to give a full description of that transformation. Now, at first sight, this looks like a reflection. But to confirm that it is a reflection, we have to check to ensure that the properties of a reflection in a mirror line are satisfied. And the first property of a reflection in a line is that the orientation of the object is reversed. So on the object here, the orientation LMN is anticlockwise. LMN is anticlockwise. LMN around the object here is anticlockwise. If we look at the image, LMN is clockwise. LMN is clockwise on the image, and so the orientation is reversed. So that is telling me that it is looking like a reflection. And remember now that also in a reflection, image distance from the mirror line is equal to object distance from the mirror line. It therefore means that the mirror line is halfway between corresponding points. And so the mirror line will be halfway between N prime and N right here. And so the mirror line will pass through this point. This point is halfway between N and N prime. And so the mirror line will pass through this point. Mirror line also is halfway between M and M prime, which is right here. And therefore the mirror line also passes through this point. And so since the mirror line passes through this point and this point, it means that the mirror line is a vertical line through here. A vertical line which passes through 7. This is 6, this is 8, this is 7. And so the vertical line down here is the mirror line. The equation of that line is x equals 7. Equations of vertical lines on a graph is x equals a number. That's the equation of a vertical line on a graph. X equals a number. This line passes through 7. All points on this line, the x value is 7. Right here, the x value is 7. Here, the x value is 7. All points on this line, the x value will be 7. And so the equation of this line is x equals 7. And therefore, our transformation is a reflection in the line x equals 7. This is a mirror line for that reflection. And so we can give that description. Our transformation is a reflection in the line x equals 7. And that's the answer for part 1. Now part 2 is asking us to draw the triangle L double prime, M double prime, N double prime, the image of triangle LMN under a translation given by the vector 0, -3. Now this 0, -3 means that there is 0 movement in the x direction, while there is a -3 units of movement in the y direction. So what it means is that this triangle LMN, undergoes a translation. Remember, translation is a transformation where your object moves from one location to another without turning. It just changes its position. And the vector under which this transformation is taking place, this transformation is 0, -3. 0, as I said, means no movement horizontally, no movement in the x direction. The -3 here means we're moving the triangle 3 units negative in the negative y direction, meaning 3 units downwards. And so the motion is simply 3 units downwards. That's it. Triangle LMN is moved 3 units downward. That's what this vector, this translation vector, will do. And so we can look at the diagram and show that translation. This triangle will move 3 units downwards, and that is done by moving each point 3 units downwards. So L will move 1, 2, 3 units down to here. M will move 1, 2, 3 units onto here, and N will move 1, 2, 3 units down to here. And we can show that movement. Each point move 3 units down, and so the triangle L double prime, M double prime, N double prime is this triangle. That's it. That's the result of that translation. 0, -3. 3 units downwards. And that's the answer for part 2. Let's move down now to part 3. Now part 3 wants us to describe a combination of two transformations that would map triangle L double prime, M double prime, N double prime onto triangle L prime, M prime, N prime. In other words, what combination of two transformations will map this triangle onto this triangle? And simply, we can take this triangle and move it 3 units upwards back to this triangle and then reflect over the line x equals 7. That's one way. A translation 3 units upwards followed by a reflection in the line x equals 7. That will map this triangle onto this triangle. Or we could do the reflection first and reflect this triangle over the line over onto here, and then do a 3 units movement upwards, a translation 3 units upwards to here. And let's animate and show those transformations. So that's it. We could do a translation 3 units upwards to here, and then we could do a reflection over the line x equals 7. That's our first option. And notice that the translation was parallel to this mirror line. So a translation parallel to the mirror line 3 units upwards followed by a reflection in the mirror line x equals 7. Otherwise, we could do the reflection first. So let's show that. Starting back with this triangle L double prime, M double prime, N double prime, we could do the reflection in the mirror line first, and that's it. Do the reflection first and then do the translation 3 units upwards, and that's it. 3 units upwards. The result is the same. And again, the translation is still parallel to the mirror line. That combination of two transformations, where one is a translation parallel to a mirror line followed by a reflection in the mirror line, is called a glide reflection. And that's what we have. This triangle is mapped onto this triangle by a translation parallel to the mirror line followed by a reflection in the mirror line. Or we could do the reflection in the mirror line first and then do the translation 3 units upwards. That transformation is called a glide reflection. Once we have a translation parallel to a mirror line in combination with a reflection in the mirror line, that transformation is called a glide reflection. And this is a breakdown of it. A translation parallel to the mirror line, in this case it will be 3 units upwards, and so this would be the translation vector. No unit horizontally, but 3 units upwards, and that's it, 3 units upwards. And the second transformation would be a reflection in the line x equals 7, and that's our glide reflection, a combination of two transformations. And note, we could do 1 followed by 2. We could do the translation first and then the reflection. That's 1 followed by 2, as I've shown in the animation here. Or we could do 2 followed by 1. That we could do the reflection first and then the translation. The result is the same. And remember that this is a glide reflection simply because the translation is parallel to the mirror line, and then there's a reflection in the mirror line. And that's what this combination of two transformations is, a glide reflection, a translation parallel to the mirror line, and a reflection in the mirror line. And that's the answer for part 3 of question 6b. So that's the end of this question 6, and we'll do question 7 in the next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.